So I love the intersection of both psychology as well as learning, and specifically machine learning, although you could argue that learning in the real world and machine learning are pretty much the same thing. There's this particular effect that we're all subjected to on a daily basis, but we don't actually realize. And this effect is called the peak shift effect. Now, if you go to Google and you just key in the words peak shift, you'll find some very vague research papers on discriminatory learning. But let me explain what it is in the real world. So if you train a rat in an experiment and ask it or train it to respond to, say, a square, you give it some food when it identifies a square or makes some sort of reaction to a square. Over time, what you'll realize that the rat has exaggerated responses to exaggerated versions of the square, right? So if you show a rat a square and it's responding, and you show a rat a bigger, more extreme version of a square, then you'll find a more extreme response. And more often than not, you'll find the rat more gravitated towards the extreme version of the square. Now, in the human world, that means that we are more drawn towards extreme versions of things we already respond to. Like a caricature is a more exaggerated version of a human being, and our response to a caricature is much higher than our response to something that's normal. Now, I'll tell you why this happens in animals. So if you look at the bee ecosystem, and I'm talking about bees, right? Honeybees, they are more likely to gravitate towards a novel flower. And by novel, I mean, if they generally gravitate towards a yellow flower, then they're more likely to gravitate towards a flower that's even more yellow or deeper shade of yellow. And that's the peak shift phenomenon. And the reason it happens is to actually prevent misidentification. So if the bee is given two options, one with a pale yellow flower and one which is a deep yellow flower, the bee will more likely gravitate towards the deeper shade of yellow to prevent misidentification. The bee might think, okay, that paler shade of yellow, it could be a white flower and could not have what I'm looking for. Whereas with the deeper shade of yellow, even though it's more novel, I'm less likely to be wrong. Now, one of the biggest examples of peak shift I've seen in the real world is Instagram. If you scroll down Instagram, you will just realize this is entirely peak shift, right? Exaggerated versions of human beings, more aesthetic human beings, and you know what I'm talking about, better food, better places, things that we normally respond to, but better versions of those, visually better versions of those. And that's what gets the highest amount of engagement. If you look at YouTube's content creator academy, and they have some content on how you can actually be a better content creator, one of the things they mention is, hey, if you have fancy cars or a fancy house, or you're at fancy places, or you have better food, involve that in your videos because they get better engagement. Today's social media is driven entirely by the peak shift phenomenon. And the more you know, the more you understand why you're doing it or why you're attracted to this. The reason it gets better engagement, and the reason that when we do ads at Avalon, we try to engage the peak shift effect, is you're less likely to scroll past it. You're less likely to misidentify it. It's the same reason a bee gravitates towards a yellow flower. It's the peak shift effect.